Hello everyone. Welcome to this walkthrough of my Capstone project for the Google GenAI intensive course. My name is Joel Jose and I am a global solutions architect at Cisco, focusing on GenAI solutions in AI ops. And today I'll show you how I build an AI powered research assistant that can transform how we work with academic literature. As someone who leads the global AI ops workshops, I'm constantly faced with the challenge of extracting meaningful insights from vast amounts of unstructured data. The same challenge exists in academic research, where professionals struggle to digest the overwhelming volume of papers published every day. Let me take you through my solution, a complete system that extracts information from research papers, discovers semantic connections between them, and even generates comprehensive literature reviews automatically. Before diving into the solution, let's understand the problem. Academic researchers face several significant challenges. First, reading and synthesizing large volumes of research papers is incredibly time consuming. Just think about the last time you had to go through dozens of papers for a project. It can take weeks. Second, extracting structured information from PDFs is tedious and error prone. You're constantly copying and pasting information, trying to maintain consistent formatting. Third, finding truly relevant papers for specific research topic often feels like looking for a needle in a haystack. Keyword searches only get you so far. And finally, creating comprehensive literature reviews requires significant effort and expertise. You need to identify patterns, contradictions, and gaps across multiple papers. These challenges aren't unique to academic research. In my work with AI ops at Cisco, we face similar issues when trying to make sense of monitoring data, logs, alerts, etc. The underlying pattern is the same. How do we extract meaning from the vast amounts of unstructured information? My solution leverages several GenAI capabilities I learned during the intensive course. Let me break them down for you. First, document understanding. The system extracts structured information from PDF research papers, pulling out titles, authors, abstracts, and key findings automatically. Second, embeddings. Each paper is converted into a vector representation that captures its semantic meaning, enabling much more powerful search capabilities. Third, retrieval augmented generation or RAG. The system can generate literature reviews by first retrieving relevant papers and then using them as context for generation. Fourth, structured output generation. Instead of just extracting text, the system formats the information consistently for easier analysis. And finally, vector search. The system finds semantically similar papers using cosine similarity between their embeddings. The architecture consists of three main components. Um, I will share about that. Before discussing about the architecture, all you need to do to use this notepad or this Jupyter notebook from Kaggle is to copy the notepad into your account. You'll find it in the top right corner, and then you install, so automatically the dependencies are installed for you. From your side, you need to set your Google API keys. Now Google provides Gemini keys, Gemini model, and you are able to create free keys, which has rate limits, but then you're able to create your own personal keys which you can attach to the um, Kaggle notebooks, right? And you would need to add your own PDFs papers. Currently, two examples are given in this notepad using curl. So if you want to add your own PDFs or add more PDFs, you are encouraged to add the curl commands as required, right? And then you can execute this to get you the results. Do note that for the demo, we have commented out certain menu options, and then we have pre-populated the menu with literature review, which is the focus of the demo. In case you want to semantic search or keyword search or find similar papers, these features can be done by just uncommenting out the demo code and making you interact with it accordingly. So let's get back to the architecture. So the architecture consists of three main components: a document processor that extracts text and structured information from PDFs, a semantic search engine that enables powerful search functionality, a literature review generator that synthesizes information across papers. Right. So I'll highlight a few components and show you how they work. So first, the paper processor. This class, so I'll just highlight the components. This is all the requirements and other things, downloading on the paper, and then we come to the main code. We initialize the systems, and then we come to the LLM wrapper, which wraps the LLM, the code, and then we come to the paper processor class, right? So the this paper processor class, this class handles PDF text extraction and information extraction using Google's Gemini model. Here you can see the extract paper info method, right, which first extracts text from a PDF and then uses a carefully crafted prompt to extract structured information. The prompt is crucial. Let's get to the prompt. The prompt is crucial because it specifically asks for the title, the year, authors, abstract, and main findings, and provides an example of the expected format. So it's a few short, it's not zero shot, it's a few short prompting method. This prompt engineering ensures we get consistent structure outputs that we can work with programmatically. Right. Next, we go to semantic search engine. I'll share that. Just give us a moment. Scroll down. So, right, second. This is paper semantic search engine. Yeah, sorry. So, and the semantic search engine. It took some time for me to find the code. Sorry for that. So, yeah, coming back to semantic search engine, it creates, so this creates embeddings for semantic search. I could search for papers related to specific topics, but for this demo, I've set it to automatically generate a literature review, as I mentioned previously. Right? So this functionality is where the cosine similarity and other matches are done, so that you can find similar papers if required. So the code is self-explanatory. You can have a look at it. Okay. So now we'll just see the whole uh, code working in tandem, right? So essentially, it goes to the PDF directory, it gives the papers to the paper processor, and then the paper processor saves to the CSV. We use the CSV files as a intermediate storage and formats instead of JSON, because I felt it is more simpler to use CSV for this particular use case. So in semantic search, we have these things, and then finally the menu options are available. And as I told you, I've predefined a particular choice for today's demo purpose, right? So we're going to mostly look at the literature review, which assimilates all the information. Then we have also predetermined the topic that will be used for the literature review. That's the agentic AI, right? So I've taken two papers from the open repositories and I've put it here, so we can see how it works, right? So I'm going to do a run all, and we're going to see it run, and the output will come here in this column. Let's see here, it's extracting the papers, it saved it to CSV, it processed the papers, right? And then it's doing literature review, right? That so as you see here, this is the final answer. This is the literature review that is conducted, right? You see, I have an introduction. So it took two papers and it has merged both of these papers and considered them for the combined literature review. It found thematic analysis out of two papers, and then it gives citations correctly, right? And then it tells you what are the research gaps. Then finally, the conclusion and the references. This gives you a very good starting point for literature reviews, and you can use this code. You can extend this further. There are a lot of possibilities, right? You can use this for. Now, definitely there are limitations, and definitely opportunities to expand this further, right? So while the system is powerful, it does have limitations. The document processor struggles with complex tables, mathematical formula, and non-English papers, and very long papers. So either a single paper being very long, or again with the context of the new very large context supported by Gemini. I don't think there will be a paper that will be long enough to uh, reach it. But then, if you want to, let's say, target multiple papers, right? So then you will have to synthesize a lot of papers, maybe um, in 50s or hundreds of them, right? So in those cases, yes, there will be at some point the context can be exceeded. Hence, you'll have to find ways around it, like chunking strategies or managing the context window somehow, etc. Right? And then there can be minor formatting errors in the generated citations as well. Okay. Looking ahead, there are exciting improvements we could make. Adding multimode understanding for better processing of figures and charts, right? Implementing clustering to automatically organize papers by topic, so that will help in scale. Developing citation graph analysis, developing user-friendly web interface for researchers. So there are multiple options, right? What excites me most about this project is how it directly connects to my work in AI ops as a scope. Because the core patterns, extracting structure from unstructured data, finding semantic connections, and generating insights are exactly what we need in modern IT operations. And then seeing how the different models operate, uh, from state of the art model like Gemini, we have different models, and then we have the open source models, and then we have on premise uh, deployment. So there are lots of combination deployment on the edge. Gemma is a very strong candidate, which deploys in the edge very nicely. So there are so many options available, and I'm very excited about the future. And the capstone and the course was very nice. It introduced us to lots of concepts as well as state of the art uh, techniques from Gemini and from Google. So that was very good from my perspective to understand and comprehend what's happening in the field today, right? And then, so I hope so. The techniques demonstrated in this project, as document understanding, embeddings, and RAG, are transforming how we approach these challenges, whether in academic research or IT operations. GenAI is helping us not just collect data but truly understand it. I hope this walkthrough has given you ideas for your own GenAI projects. If you're working in AI ops or research tools and want to discuss these applications further, feel free to connect with me on LinkedIn. Thanks for watching. Right. Thank you.